Hello class, today we're going to be talking about FRQ 2015 number 5. And the question is going to say, consider the function f of x equals 1 over x squared minus k of x, where k is a constant. The derivative of f is given by f prime of x, k minus 2x all over x squared minus kx x all squared. Now, let's move on to question A. It says, let k equal 3 so that f of x is equal to 1 over x squared minus 3x. Now, they're asking you to write an equation for the line tangent to the graph of x at the point whose coordinate is x equals 4. So, now for question A. So to find the equation at x equals 4, you're going to need to find two things, the xy coordinate and the slope. So how we're going to find the xy coordinate is we're going to plug in x equals 4 back into the original equation. So we're going to plug in 4 for x, and then we plug it in, we're going to get 1 over 16 minus 3 times 4, which is 12. So it's going to be 1 over 16 minus 12, which is going to equal 1 over 4. So then when we found our xy coordinate. It's going to be 4, 1/4. Now for our slope, it's going to be really easy as well. All we need to do is just plug 4 into the derivative of the function. And they've already given us the derivative of the function. So, we're just going to do 3 minus 2 times 4 over 4 squared minus 12 all squared. And that's going to simplify down to negative 5/16. Now we have our slope too. M equals negative 5/16. Now, all we need to do is just plug it into the point slope equation, and it's going to be y1 minus y equals m times x1 minus x. So we're just going to plug that in. We're going to get y minus 1/4 equals negative 5/16 times x minus 4, and we just add that constant 1/4 to the other side, and we get y equals negative 5/16 times x minus 4 plus 1/4. So now we're on to question B. Let k equals 4 so that f of x is equal to 1 over x squared minus 4x. Determine whether f has a relative minimum, maximum, or neither at x equals 2. Justify your answer. So this is going to be a really easy procedure, just like question A. So all we have to do is just plug 2 into the derivative and find out if it equals 0. That's how we know it's a critical number. Now our derivative is already given, so all we have to do is plug it in. So we're going to get 4 minus 2 times 2, which is just going to be 4, all over 4 minus 8 squared. So this is going to end up equaling 0, so that means it must have a coordinate that is max or min. So how we're going to test that is we're going to find one number that's less than 2, one number that's greater than 2 to test the line and see whether it is positive or negative in front or behind of at x equals 2. So we're going to plug in x equals 1 into the derivative equation, and we're going to get 4 minus 2 times 1 all over 1 minus 4 squared. So that's going to end up to be positive 2/9, which means that behind 1 or before 1 or anything less than 1 is going to be positive. Now we're going to test x equals 3. Now we just plug it in again, same as the first one. 4 minus 2 times 3 all over 9 minus 12 squared. Now this one's going to turn out to be negative 2/9, so that means everything greater than 2 in the graph is going to be negative. So this means that at x equals 2, it goes from positive to negative at x equals 2, which means that there is a relative max at x equals 2. Okay, so now we're on to our third question, part C. Find the value of k for which f has a critical point at x equals negative 5. So we've already went over critical points in the last question, so this is going to be pretty easy. As I said, a critical number is when the equation is equal to 0 on the derivative at that certain number. So all we have to do is plug in negative 5 into the derivative equation and set it equal to 0 and find k. So what we're going to get for our plug-in equation is going to be k minus 2 2 times negative 5 all over negative 5 squared minus k times negative 5 squared equals 0. So now we're going to simplify all that down to be k plus 1 over 25 plus k squared. Now it's going to be simple algebra from now on. We're going to just multiply 25 plus k squared to the other side. So it's going to be 0 times 25k squared, and the bottom is going to cancel out. So all we're going to be left with is k plus 10 equals 0. Now we just subtract 10 to the other side, and we find out that at x equals negative 5, k is equal to negative 10. So now, class, we're on to the last question, part D. Let k equal 6 so that f of x is equal to 1 over x squared minus 6x. Find the partial fraction decomposition for the function f. So basically we're just going to find the integral with PFD. So for PFD, we get to start out by separating and factoring out the bottom. So we're just going to take out x. We're going to get 1 over x times x minus 6. So now we have to figure out what to do next. So now we have to set everything equal to 1 equals a over x plus b over x minus 6. And now we can eliminate the fraction overall. So we're going to get, by multiplying a times x minus 6 and b times x minus 6. So we're going to get 1 equals a times x minus 6 plus b times x. Now we're here, so we need to solve for a and b, and how we're going to do that is we're going to set either one of them in two situations equal to 0. So either a is going to be equal to 0 or b is equal to 0, so we can find either a or b. So those two numbers that we're going to set those equations to is going to be 0 and 6. So at x equals 0, 1 equals a times negative 6, since b is equal to 0 at this point. So all we need to do is just divide negative 6 over 1, and it's going to equal a equals negative 1/6. Now we're going to x equals 6. At x equals 6, a is equal to 0. So we're going to get 1 equals b times 6. b is going to equal 1/6. Now we plug back 1/6 and negative 1/6 back into the equation. And we're going to get the integral of negative 1/6 over x plus 1/6 over x minus 6 dx. Now all we have to do is just simple integration, and we know that 1 over x or 1 over u is going to be ln of x or ln of u. We can just take out the constant. So we're just going to integrate it and get negative 1/6 ln x plus 1/6 ln x minus 6 plus c. Now we can't just leave it like this. We have to simplify it down. So we're going to use the logarithmic rules and find 1/6 ln of x minus 6 over x plus c. Thank you for listening, and if you want to practice more problems, look at the description below. Thank you.